Welcome to this tutorial on industrial instrumentation. Today we'll talk about temperature measurement part 2, and the topic that we'll cover is expansion thermometer biometric strip. The content of discourse is expansion thermometer biometric strip or thermometer. This comes under expansion of solid. The biometric strip is a temperature indicating device that is made up of two dissimilar metals or alloys that have different thermal expansion coefficients and therefore different heat expansion rate. As two metals or alloys are involved, therefore it is called the biometric strip. The two metal strips are bonded together by means of welding, brazing or riveting. The biometric strip is fixed at one end and free at the other end. The free end is heated and based on the temperature expansion rates, the two metals expand differently, thus bends inward or outward accordingly. The bending curvature is measured, which is the indication of the temperature. The strip is attached to a pointer arrangement to ease the temperature reading. The operational range of the biometric strip is from minus 103 degree Fahrenheit to 1000 degree Fahrenheit, or in Celsius from minus 75 to 550 degrees Celsius. The Timoshenko formula for determination of the radius of curvature of biometric strip R is given as R equal to T whole into 3 into 1 plus m whole square plus 1 plus mn whole into m square plus 1 by mn by 6 into alpha 2 minus alpha 1 into th minus tc into 1 plus m whole square, where T is the strip thickness, m is the thickness ratio and n is the elasticity ratio. The strip radius is calculated by the following equation, alpha being the mean of the elasticity of the two metals or alloys, R equal to T by 2 alpha into Tf minus Ti. Similarly, the temperature is indicated by using the below formula where Tf and Ti are the final and initial temperatures respectively. Tf equal to Ti plus 2T by 3R into alpha A minus alpha B. The angular deflection that is experienced by the biometric strip is given as theta equal to strip length by the curvature of the radius. And finally we have the vertical strip displacement given as y. The corresponding vertical displacement from the base of the strip is given as y equal to r into 1 minus cos theta. Here we see both the helix type and the spiral type biometric strips. In both the cases we see that a shaft is attached to the free end and the shaft is further attached to a pointer arrangement which is calibrated on a temperature scale. There are a few criteria that need to be checked while we choose the combination for the biometric strip. These properties are as follows. The individual expansion coefficients of both the metals or alloys that are used in the strip, the respective modulus of elasticity, the elastic limits of the elements that when they are cold rolled, the electrical conductivity of the strip element, the individual ductility and their individual metallurgical abilities. The commonly used elements for biometric strips are brass, nickel iron alloyed with chromium and manganese for high expansion uses, and invar, which is an alloy of iron and nickel for low expansion uses. The biometric strips do come in four common shapes, which are helix, spiral, cantilever and flat type. The areas where these strips find application are in temperature controlling devices, in the air conditioning thermostats, and in refineries, burners and vulcanizers where we use the helix biometric strip. The advantages that are offered with the biometric strip are it is simple in design, robust in build and inexpensive in cost. The device is easy to install and maintain. It can tolerate an overrange of up to 50%. The device has an accuracy of plus minus 2 to 5%. The limitations of this device are that it only supports local mounting, it is only of indicating type and not of integrating or recording type. the device calibration is affected upon rough handling, and the device is not suitable for temperature measurement over 500 degrees Celsius. For more detailed and further reading, the students can refer to the following links and references. Thank you.